don't be shy, because we're about to show you how cars can fly.
Who dares to fight with the icon of his day, and she finds her own miracle on the way. I said, hey now, life's a joy. You gotta try your best and give your all, and when the facts don't fit the theory, change the facts again. Ooh, I've seen it, though you won't believe it. It's a miracle year in which we're living. Come on outside, it's a beautiful day. It's a beautiful day.
5, 4, 3, 2, 1. Silence. I love that song. In fact, what's really interesting is my composer has moved to Florida. Going to see him tonight, Michael Ruggieri. If you haven't seen the movie EinsteinWrong.com, you got to check it out, man. The music is absolutely phenomenal. He and I are working on a secret project that actually is very, very similar. But no one's going to know that for about a while. But if you want to check out that song at least, it is great. We have a music video that goes with it. But of course, you've reached Saturday Science Chats. Good morning, good evening, good afternoon, depending on where you are in the world. Yeah, I thought I would wear a non-scientific t-shirt today. Samba, yes. Work, no. Yeah, I lived in Brazil. I love samba. We have a samba group, do a lot of fun things. Samba is a great art form, both music and dance. And if you haven't been to Rio de Janeiro and see the amazing parades in their Samba Dome, you gotta go there. Put it on your bucket list. You got to check that out. And of course, today we have our chats, and we've got a great show for you, sponsored by, of course, the John Chappell Natural Philosophy Society, and of course, Dissident Science. I want to welcome all the subscribers from my Dissident Science chat YouTube channel, as well as almost reaching 1,000 our CNPS YouTube channel. We're going to be talking to James Marsen today on the local ether theory, a viable alternative to relativity. Why don't they put more spaces in that font? Come on, that's pretty sucky. So you don't want to miss that. And of course, I want to thank everybody. Yeah, I had to change my photo because I've gone natural gray now. I can't take it anymore. But I want to thank everybody who is watching, because it is without you guys, this wouldn't be here. Of course, and this is the only show in the world like it. Well, it's the only show in the world that brings on people with alternative ideas who challenge mainstream ideas and do it in a very scientific way. Not going to find anything else. So make sure you like and subscribe. Put that little bell there so when we go live, you'll be alerted when we have our next show. So I want to thank everybody out for their support. Both also, if you're watching this recording, make sure you do hit the like button and subscribe. That does help us get the word out there. So we're Critical Thinkers Meet. The John Chappell's named after a doctor. I can't remember where he's from. It was something like, I don't think it was Harvard, but it was someplace like that. He was a doctor of philosophy, I believe, but he started the Natural Philosophy Alliance back in the early 1990s. He passed away in the early 2000s, and we keep his legacy alive. We changed our name in 2015 to the John Chappell Natural Philosophy Society in honor of what he'd started. And of course, we're an organization that above all promotes critical thinking without malice, an organization that supports, publishes, and promotes serious work outside mainstream science to provide a forum for open debate about modern topics in physics, cosmology, philosophy, and mathematics, and to provide a forum for presenting serious papers and theories without fear of censorship, to be run and desired by our membership. And of course, memberships are how we keep going. So who we are, of course, we are open to challenging mainstream ideas, allow and encourage competing ideas or models, which is about every other profession except physics and cosmology, which is very strange. And of course, we do follow the scientific method. People think we just throw everything out. It's not true. Of course, as well, we can consider an idea without accepting it, and that's what I would encourage everybody to do. So if you are not somebody says about a half a foot away. Oh, is that too loud? Am I too loud, folks? Sorry about that. How about this now? Is that better? All right. Somebody was complaining about the mic. All right. Anyways, we do give voices to the voiceless, and we're mainstream advances. It always, actually, science advances doesn't happen inside of mainstream; it happens outside. We are not a specific point of view, so we have many different points of view. We're not a general science organization. We pretty much stick to foundational physics and cosmology. Not New Age, not conspiracy or UFO. We've got too many things to worry about, like the foundational science, light, gravity fields, etc., magnetism, tectonic plates. It's all that. And we do have our website. Actually, it's not a new website. It's just been rebranded to beyondmainstream.org, our online magazine for critical thinkers. And we have philosophy and naturalphilosophy.org, which is our community where you can go and discuss things with people. If you have ideas about what's going on in the universe, you can do that. And of course, our Wikipedia, we have a real Wikipedia, meaning the same software as Wikipedia, but it's the wiki.naturalphilosophy.org, and that is a Wikipedia where we have all of our over 10,000 pages of abstracts and books and people and scientists who are working outside the mainstream. Of course, we survive on our monthly memberships and our annual memberships and our donations. We get all of those. So you can go to our page, and that is, I need to put that's from at naturalphilosophy.org, and that's where you pay your membership, and after that it will just automatically charge you. Some people actually do the monthly membership of $5 a month. That's easy to do, and that gets you $60 a year. All that helps pay for this couple $1,000s worth of things we have to do and pay for on the internet, from server to the software we use that is subscription based, which is everything now, and also our things that we do, such as StreamYard, which is the internet service that you're watching now, which costs us a monthly fee. And of course, we also accept any kind of donations, and we do have people do that, donate $50, $100, even more than that. So we accept anything, any donation, but the monthly or annual memberships are the things that really obviously keep us going. I want to thank our patrons, Dr. Cynthia Whitney, our Chief Science Officer, and Nick Percival, Duncan Shaw, Anonymous, Bob D. Hilster, Kurt Renshaw as some of our patrons. Also, we have our CMPS conference coming up, 2021. We are currently accepting papers. And just to whet your appetite, I'm writing a paper on why data transmission via ether is not a optimal way to do it. In fact, there's a lot of problems there if you look at it in a data transmission. If you look around you in the world and you see all the amazing information you get from your eyes, being able to transmit that through basically particles that stay in the same place, it's really hard to do. So I'm going to be writing a paper on that problem with ether. And we have other people. I know Jeff Yee is going to be submitting a paper. And if you have a paper that's already been published or put on the internet and on a website somewhere, I don't know, there's all kinds of places people put them there, hoping that they'll be discovered by mainstream, and Oxford will come calling and you become the head of same place as Newton. Well, who knows? Could happen, but you can publish in our proceedings, and we will have our we've already launched, and we are taking people's submissions, and we also have the we use the overleaf system. I need to put that down there for the papers, and allows you to do it. We don't use Word, we use overleaf. It's pretty easy to use, so if you haven't used it before, then that's okay. We'll teach you. We have my dad who will help you with that, but that way we can put it all together, and that allows us to get the go until about 2 weeks before the conference, actually, and still have papers in the proceedings and get them out in time. So anyways, we're going to be taking place in the fall of 2021, Northern Hemisphere fall, that is, and we're going to be having presentations that will be recorded presentations for each of the papers, so people can watch those ahead of time, and then we'll be having Zoom meetings where people can get together like they're in a room and discuss those papers and ask questions. We had a meeting about that. If you can look, you want to do it, go back and look up our YouTube on our YouTube channel, either on the CMPS YouTube channel or the Dissident Science YouTube channel, and we did a session on how we're going to be doing this, and a lot of good ideas came out of that. So that's going on. Of course, we are publishing. Notfinity is ready to publish. I haven't talked with George on that, but I think he's working on that, getting it out there. Ready to publish is Ramsey, his book called Ether. That is E-T-H-E-R, even though we like to spell it E-A-T-E-T-H-E-R, because ether is actually a gas, and that's not what people are proposing. So we try to use the E-A-T-H-E-R spelling normally, but that's why he did it. That's not a big deal. Then, of course, we are in the final version, and people are reviewing, and we're getting our reviews from about 10 people who are reviewing it, not in the sense of, this book's terrible. How can anybody say the universe? No, it's not a review or, oh, this is the greatest model ever. No, we're actually having these people read it for clarity, for problems in how we say things, how we communicate things. The good news is, I can tell you some of the good things. People really say it's not a boring book at all, because there's a lot of graphics in it, because our model does not rely on mathematical equations. It relies on intuition. So I actually wrote some programs in Adobe Illustrator, and to, for instance, generate random particles going in directions, sometimes in same directions, and they're all drawn differently, which really makes it, which is what we think, because no two particles in the universe are alike, according to Borkert, and we subscribe to that. But anyways, people are liking that part of it. There's a lot of great graphics in it. Working on actually an index to the graphics, because so many people like it, where you go in the back and read it, and you think of something, you want to get to a graphic to go to the page. And then we actually have a hack, at least a hack, we think, for diffraction, which came up, I don't even what day. My dad's online, but I don't remember what day it was. It was either yesterday or the day before. What day, Dad? Oh, I don't hear you. Okay. Oh, that's because I have to bring you up. Okay, don't. My dad, of course, fell down. What day was that, Dad?
We talked about this diffraction yesterday.
Oh my gosh, I'll bring it down, because people are like, yes, my dad's recovering from a fall, and they asked me in the hospital, are they abusing you at home? So, I gave him an answer. When he fell, he was in the hospital, just for precautionary observation, etc. They said, "Are they abusing you?" And I didn't say this, but I said, I think I said it on Facebook. Yeah, my son's forcing me to write a physics book with him. I thought it was funny. Anyways, I'm sure. Anyways, it's an interesting book. We did have in our book, we plan not to have a hack for diffraction, but it turns out that we have a hack for diffraction and dispersion. Why do rainbows happen? And yes, we don't use ether. So interesting, but it's just another model out there. I think people will find it interesting. And then our community news. James Keen is starting to put out some of these things. We did this. I need to rebrand them all because we have a lot of memes that we put out, that I put on Facebook, that have really clever sayings to get people interested. And it has science woke. Now I got to change all the science woke to beyond mainstream. So I'm going to have to rebrand those and get those out there if you go to that. So I'm not going to tell you where they are because we do need to update those. But you can see this says this guy has a paper in Physics Review without citing binary mechanics. Obviously, James Keen, his theory is binary mechanics, and he's got the famous Godfather scene here, and he says, "Put a primary constant in his bed while he's sleeping." You're referring to the horse's head. Very famous. Oh, that was pretty clever and funny. These things are on naturalphilosophy.org, so you can go there. This was another one I found on Facebook. I think it was done by a guy that he has agreed to be talk with us. Is carrying on Edward Dowdy's work, and I think he did this and change it. So, you grab one of these cartoons and then you just change the words on it. So it says, don't question me. And the next one says, don't question this book. The other one is why I don't question anything. And then, of course, a person is standing there and says, and that's giving a talk to his professors or students. And he says, and that's why I never question anything. You see him very happy getting his, I should get my pointer out here. You can see him very happy, of course, getting his diploma, and there he is sitting in his office now with his PhD in relativity. Pretty interesting. Of course, our chief scientist does have a PhD in relativity from MIT, and it doesn't work. So that's very interesting that she got a PhD in relativity and the first application for it didn't work. So anyways, I guess that doesn't happen. Now, here's some interesting community news. For those who don't keep up with social media and don't care about it, that's okay. But of course, that's where the world works. That's why we are getting new people and new faces, and our CNPS website and our organization. So you can say it doesn't work. I don't pay attention to it. But guess what? That's where people are today, and we get people from that. And we make a great presence on YouTube and also on Facebook. And there is another one out there, and I've tested the waters, and it is fantastic. And if you have not gone to Clubhouse, you're going to probably think this is too screwy. I mean, especially people who are older. I'm 61, but of course I grew up. I started programming when it was in 1978, before almost half the people here or more weren't even born. And I have always followed the internet because I was in research in artificial intelligence. We actually were using a browser before anybody even knew that was. That was in the early 1990s. And so I've always kept up to it with it, and I know that's where things are happening. Well, Clubhouse is the latest. Well, what is Clubhouse? It's a new social media platform that is on fire. No, it's not like TikTok. It's actually being used by not young kids. It's actually more professional and older people in general. This is not where you'll find kids. So it is on smartphones only. You're going, why? Why would anybody do that? Well, guess what? 60 to 70% of all interaction in the internet is used on the phone. Well, what makes this interesting, it's audio only. You don't have to worry about video. And you go in and you can I don't even have a picture of it. But basically, I should have put a picture of what that is. But I think I may have. I know. I can share a website and show you later on. But anyways, if you want to join in, what's happening is I created a club. On Clubhouse, you create clubs called Beyond Mainstream Science, and you can see here our new logo, which is there's the stream, and oops, somebody's going off mainstream, and of course, the color is there. That's water. This is red, being alert. Somebody's going. I think everybody gets it. Anyways, I've created it, and you can actually. What I did is on beyondmainstream.org. You can put these, of course, sub domains, and if you go on your smartphone, I'm going to say it again. If you go on your smartphone with this, and you go to your browser, you put this in, it will get you and say, do you want to join? And this is the page you will see. David D. Hilster invited you to Clubhouse. And you put in your phone number. Yes, all works on phone number. And then you say next, etc., etc. Now, what does Clubhouse do? Well, I've also joined in on it in 2 other areas that I'm interested, which is whole plant-based diets, which I'm on, reverse my heart disease, rheumatoid arthritis, and my allergies are gone. All those things are gone because of my diet. But again, I'm just talking about the subject matter, and there's like 150,000 people in the whole plant-based food groups, and people will, during the entire week, will put together a group and start discussing. What's really great is if you're working like I do, computer programming, and I'm no one's out in my office while I'm programming, I can listen in on those and participate just with my voice. You don't have to watch, you don't have to worry about video, and it's quite interesting. And they got all these little rules that go on. So you have moderators, and they let you in if you can raise your hand if you want to have a question or a comment, and all kinds of things that there are formalisms that have developed, and it is on fire. I did this for my computer programming language called NLP++. I'm in the area of computers, supercomputers and human language, and invented this new language, which is now about 20 years old, but now is open source, et cetera, et cetera. And I got on there and I started talking about it, and wow, there was lots of interest. And I already made one called for Dissonant Science, but I decided to make another group called Beyond Mainstream Science because it's probably less controversial, and people are already signing up for it. So please, please, please go there. Even if you don't use it, I try to tell people, I don't pay attention to it. That's not my thing. Oh, and then they tell me at the same time, well, you know, why doesn't anybody pay attention to my work? What do I need to say to you here, folks? If you don't like social media, if you think it's a joke and you don't want to participate in it, and at the same time you have things you want to say and other people to listen to, you have a paradox, a grand paradox, because that's the way the world works. We don't have typewriters, we don't have dial telephones, we have the internet, and we have a way of meeting there. And that, not only that, we have people from all around the world. I mean, we didn't have that at all. So now we have that. So if you are an older gentleman or older lady, and you have been working and you just say, I don't use this, then you're not helping yourself out. So even if you don't or plan to use Clubhouse, go to your phone, do these things. It takes a few seconds. Help out our community, folks. When you are watching this, did you hit the like button? Oh, what's that do? Well, if the more likes, the algorithms for YouTube will send more people our way. So please, all of things matter. And yes, this is a lot of fun. And I planned to have sessions throughout the week. I'm going to put up a session there when I'm working and stuff. I'm going to put it up and just discuss it maybe on a lunch hour, and people will pop in. Why do we do this? Why am I asking you to do this? Because this has millions of people coming on daily. They are gaining millions. This is like the next kind of Facebook-y thing. And not only that, it isn't the kids. This isn't TikTok where people make funky videos for 12 seconds and their attention span is 3 seconds. No, these are people discussing very amazing things, and it is a platform. So if you come up to have a question or you talk, we have all these unwritten rules. That is, hey, give a person a chance. You can talk a little bit. We cut you off and say, okay, that's good. Anybody else? Next person. But you get really amazing information. People are going to this and they're finding great value in it. So please, 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 if you're watching this recording, go to club.beyondmainstream.org. Put in your phone number. You got to do it on your smartphone, and look for alerts. So when we start a topic on something, then we can talk. And why is that important? Because we will start gathering new people into the group, just like we do with YouTube, just like we do with Facebook. All right. So that is that. And if I find other people who are good moderators, I can allow them to put their own group, to starting a group, and they talk. Again, it's all audio. It's not chat. It's not type-in. There is no type-in. Well, I think that's one of the reasons people like it, because it's super simple. You got your photo there. You talk. You unmute. You mute, and people discuss things in a very orderly manner. So, alrighty. enough of that. And play coming attractions. All right, I will do that. Where are they? Okay, here we go. Yes, sir. You saw something new there, I would imagine. But of course, Steve Bryant is. We're waiting to see if he's getting published in another place, but he is totally on board to be talking, and hopefully that will happen soon. But I am in conversations with him, so that's great. Of course, then this is a new person. If you don't know him, James Verbelli. He just got done having a huge presentation. Actually, I think that's him in a lab with like magnets and things. I think he's from more the electric universe side, but he is actually continuing Dr. Edward Dowdy's extinction shift theory, and that is quite interesting. On Facebook, you can look him up, and he's got a lot of his work in really sort of nice graphics. But I've talked with him, and he and I are going to be talking about him coming on and talking. He's got a lot to say, and of course, Ed Dowdy was a very close friend of mine in the sense of a colleague in this area. He appears in my film EinsteinWrong.com. He was a NASA scientist. He worked with lasers, I guess, in the area of astronomy, I believe. Laser astronomy, if there's such a thing, and I don't quote me on any of this stuff. But he was the person who, a NASA scientist, actually on Einstein's Facebook page, he went viral for a little while because the people on the kid who runs it and is linked with the university in Israel there, they were all worried because if a NASA scientist is saying general relativity is not correct, oh my gosh, so they were in a panic a few years ago, and he got quite a lot of attention. But he basically says that general relativity is not correct, that light and gravity don't directly interact, and that what's really happening is light is bending because of the corona mass around the sun, not because of space-time, and then outside the corona, it doesn't bend. So I guess James is continuing that work. So that's going to be interesting. Hope we'll talk to him. And yes, Dr. Alexander Unser has talked with me. He says pick a date. So I will pick a date, maybe even next week. So you do want to stay tuned. He is an absolute big thinker. I really like him. He always jokes with me, he says, well, maybe I shouldn't have written the book, The Higgs Fake, which blows the whistle on all particle physics. I mean, you got to read that, because if you think particle physics is a solid engineering and endeavor, and all of their methods are straightforward and also trustworthy, oh my goodness. Of course, he didn't endear himself, so becoming a science evangelist and making money at telling people how to understand hard things in physics is something sometimes he's said he's not sure he did the right thing, but he did the right thing in the end. He also wrote a book, Einstein's Lost Keys. You got to check out his channel. It's the Machian is called, but you can look up Dr. Alexander Unser, the Machian, TheMachian. If you look up the Machian, you'll get to his YouTube channel. I would suggest you subscribe to it. It's really good. So we'll be talking with him, and then of course we will be talking probably. My guess is in maybe July when our book comes out. It will be coming out on Amazon across the world, and complete toolkit for hacking the physical universe. So yeah, we give physicality absolutely everything, right or wrong. So today, play today's bumper, David, and that's what I will do. Make sure I pick on the right one. Yes, today we'll be talking with James Marsen about his local ether theory, a viable alternative to relativity. Good marketing, of course. If you don't know who James Marsen is, he has a Bachelor of Arts from Columbia College in Columbia University in 1970, a Bachelor of Science and Master's of, I guess, Engineering in the School of Engineering, Applied Science at Columbia. Very good university, obviously. So he must be a real smart guy, huh? MS and ME in Plasma Physics, School of Engineering and Science in Columbia University. Is he ever going to leave the university? The guy is going to become too knowledgeable. And a PhD in Plasma Physics, graduated School of Arts and Science, Columbia University, 1976 and 1979. Quite an amazing resume. I don't know a whole lot more about him because he is... so I'm going to ask him before he starts. I don't think this is going to be the only talk from him because he's got a lot to say, but I'm going to bring him on here. Let me bring this down and bring him up. There he is. Hello, Jim Marsen. How are you?
Hey, how's it going?
Very good. Thank you so much for coming on. Why don't you tell us a little bit about you, how you got into this? I didn't find a bio on you, so if you don't write a bio and don't want to talk about yourself, then this is the way to do it. So give me a hard time. But no, tell us, how did you get it? I mean, I am always curious, and I think it's always great for the audiences. Why in the heck are you even suggesting a local ether theory and saying there's better alternatives to Einstein's relativity? Just give us a little background before you start your talk here.
Well, actually, my dad had a theory about ether when I was growing up.
Oh, wow.
The Tron theory.
Oh, yeah.
I don't know if you remember, back in 2016, I gave a talk on it.
Oops, sorry. Yep, I got the wrong one. Yeah, I did, actually. So, hold on. Okay. Yeah, I did. I remember the Tron theory because it's easy to remember that name. So, yeah.
Yeah, unfortunately, the Disney, or they came along and made a movie about Tron.
Oh, that was before the Tron, right? So
Right.
was the movie named after his work?
No.
So, okay, so your dad was already into it. How old were you when you sort of knew about it? Did he force you to read about it and put you in a room and teach you and hit you with a cane if you didn't read his theory, or how?
No, we just saw what he was doing, asked him about it, and got interested in it. I've always been interested in science and engineering, tech stuff, the techie, nerd, whatever you want to call it.
Okay, and then how did you get to your theory, your work specifically?
It's
because
not
it
my
started
theory.
with Tron? Oh, it's not your theory, yes.
Well, I mean, I support the work of Professor Ching-Chuan Su.
Right.
And it was actually his theory that...
But how did you meet him then? I mean, he didn't come along as well and say, Jim Marsen, I picked you randomly out of the universe, and you are now going to promote my theory. How did you find him? Tell us the backstory on that.
No, I never met him. He actually passed away in 2006 at age 55, unfortunately.
Oh, did you know about his work before he had passed away?
Yeah.
Okay.
In fact, I was tried to send an email to contact him, and I got a letter back from the secretary saying, too bad.
Oh, yeah. 55 is young, too. Okay.
Yeah.
And what got you to him? Was it by accident? Were you looking actively? Were you just curious about ether in general and started working? Tell us that.
Well, certainly I'm interested in ether theories. I don't actually remember how I heard about him.
It's weird,
although, his theory is actually almost identical to Peter Beckman's theory. Have you heard of
okay.
Peter Beckman?
Yes, of course, absolutely. If you're from the NPA and CMPS and don't know Peter Beckman, I don't have any of his books, though.
Sorry?
I don't have any of his books.
Oh, I have. Well, anyway, I first saw an ad in Science magazine or some mainstream science magazine for his theory, and I was curious about it, and got his book and learn about his Galilean electrodynamics journal that he created. By the way, do you know if John Chappell knew Beckman?
You know, I that's a good question. I think who would know that answer for sure would be, well, maybe not. I think it's Peter Beckman, right? Peter Beckman.
Correct.
Yeah, if I were to gamble on it, if somebody made me gamble $100 on it, I would say yes. I would say they knew about it. Yeah.
Just wondering if there's any connection between CMS and
we have all the events of all the CMPS events at least through the mid 2000s, and every person that we knew was there. We have a catalog, so it could be that we could find Peter Beckman and John Chappell at the same, because John Chappell was alive until early 2000s, 2002, I think. And so if Peter Beckman and he were at the same conference, then of course they would know about it because he was in charge.
Beckman actually died in 1993.
Oh, I didn't get that part. Yeah, because there have been people that are similar to him that I did meet. So I forgot that part. Just so many people. So okay, yeah, I don't know. Then I would. My bet has just changed. I'm putting it on. I'm putting it on red now, not black. So
I think Cynthia probably must have known it because she published papers in GED.
Okay.
Before he died, I believe.
Okay. So you learned. You knew about Peter Beckman's work, and he was an etherist as well then?
Oh, yeah.
Okay.
In fact, yeah. He never called it the local ether, but it's essentially the local ether.
Okay. And is a local ether same as entrained?
Well, it's entrained with a little twist. Very important twist.
Oh, a real twist or just a figuratively twist? Okay. All right. Well, it gives me a little idea about how you got involved with this. So you're really presenting other people's ideas that you really subscribe to, correct?
Yeah, subscribe and would like to promote.
Okay, ótimo. See, like I speak Portuguese. Great, ótimo, optimum. All right. Anyways, what I'll do is I'll put your, I guess your screen up there. If you can get that as big as possible, that would be great. I don't know, can you do that? Okay, now are you able to go and still manipulate those things? Yep. Hello. He is frozen. We may have lost him, folks. I know that can happen. Let me remove this. Okay.
It's essentially a compilation of his papers.
Okay, we lost you for a while. Okay, you were frozen. So I think we're good now. So I'm going to remove.
And by the way, this is Peter Beckman's book. Hello?
I have seen the cover. Can you hear me? Hello?
Yeah, hi.
Okay, yeah, we're having a little communication problems, I think, from your end to us. So
is this share screen too tough?
No, it's okay. We'll let you go. I'll keep ahead of it. You just go ahead and go forward, okay?
Okay. So this is Peter Beckman's book that he wrote in 1986?
Yes, I did see that. I'm familiar. I've seen the cover, but I don't have it. Is it available anywhere?
Not really. I mean, sometimes you'll see a used copy on Amazon. They actually, at some point, were up as high as $700.
Oh my gosh! Well, how many pages is it?
It's like 200 something.
Yeah, so, I mean these are digitizable. You can get a book digitized. And
I have a digitized copy of it. So
well, then we should talk to his relatives and see if they want to get it out there again. It's so cheap to do. So, if you know of his relatives, maybe you get permission to republish it.
Actually, he had one major supporter by the name of Professor Howard Hayden from University of Connecticut, who actually has the rights to it now.
Oh, okay. Well, maybe we should talk to him about it.
I have emailed with him to suggest that he get it republished, but
yeah, you got to bug people. You got to get on the case.
He's in his 80s now. And,
Ay, caramba.
He
Yeah.
seems to have lost interest pretty much in the idea.
Well,
if there's anybody out there that supports these theories, I'd love to hear from you, or of you. Or
okay. Well, let's go forward, and maybe you'll get more supporters presenting this. Okay. I'll let you go. Okay, you go ahead now. Go forward. The floor is yours.
Okay. So if you want to think about the gravitational potential, okay, let me call up. The gravitational potential around a celestial body, whereas drops off as 1/r as you travel away from it. And so you can see the gravity potential field around the Earth, around the Sun, around every planet. And as you orbit the Sun, you carry that potential field with you. Okay? And the point is that this is a well-accepted concept that you can carry this. Essentially, the gravitational potential field of a celestial body is entrained with it, and most importantly, it does not rotate with it. Its effective orientation is fixed with respect to the galaxy or the stars or all galaxies. So the Earth is, as it's rotating on its axis, is spinning within that, but it doesn't spin with it. Okay? And that's essentially what the local ether is. Except that it's a real substance, has a minute mass, density, that is proportional to the gravitational potential field. So it has the same distribution in space as the gravitational potential field. And that's what Su called the local ether. That's essentially the main postulates of his idea. And as well as Beckman. Actually, the only real difference between Beckman and Su was that Beckman insisted on thinking of the local ether as the gravitational force field, G, small g, whereas Su insisted or preferred to think of it as gravitational potential field, which the gradient of is the force field. But they're essentially the same thing. And if you don't try to go into the more detailed properties of the ether, you can solve a lot of problems this way. I'm thinking of a field that, or a paradigm for physics, going back to before Einstein, absolute time and Euclidean three-dimensional space. Return to that classical paradigm. So what does that give you? It gives you the Sagnac Effect, very simply. It gives you explanation for the Michelson-Morley-Mel results, which essentially turn out to be that the Earth entrains its ether, so the motion of the galaxy or of the solar system with respect to the galaxy, or the Milky Way with respect to the rest of the universe, is that motion is essentially blocked out, and all you have but you do have motion with respect to the local ether, which, as you're spinning, provides a much lower but actual ether wind in effect. And it's so low that a second order experiment like the Michelson interferometer can barely detect it, if at all. Although Professor Hayden has a paper that claims to, where it shows that an experiment in 1979, it's the famous Brillier-Hall experiment, which was an attempt to create a Michelson experiment with a Fabry-Perot filter optical cavity instead of the traditional mirrors and on arms, like the original Michelson phenomena, and all of the repeats essentially of that experiment up until the 60s, when lasers were invented. So he showed that they actually had a result that was consistent with rotation of the Earth. Ether went due only to the rotation of the Earth, whereas the scientists who did the experiment were essentially assuming the universal ether model, where there's only one homogeneous ether. Essentially, this is flat. So the ether distribution is flat throughout the universe. So you would expect to see a velocity of the Earth either due to its orbit around the sun, which would give the 7,000 times stronger result than just due to the Earth's rotation. So that's kind of a unique explanation for why there is a supposed apparent null result to Michelson-Rowley type experiments. Another point about this ether model is that it has an alternative explanation for time dilation and essentially the dependence of the atomic clock rates on speed with respect to the local ether and the gravitational potential, whereas it's a real effect due to an intrinsic quantum property of the atom, rather than a magical result of applying Einstein's Lorentz translation. So I wrote this paper a couple of months ago, essentially an overview of Su's work. Now the Sagnac effect is one of the strongest evidences that there's a preferred reference frame within the sphere of influence of the local ether of a body. Essentially, there was an experiment called the Michelson Gale. It was done in the 20s, whereas actually Michelson probably really was the first one to promote the idea of a local ether effect, which is what inspired him to do the Michelson Gale experiment, where it's essentially a Sagnac experiment done on where the method of rotating the Sagnac interferometer, nuclear interferometer, was the rotation of the Earth. So what they did, I mean, they had a positive result, and they did detect the rotation of the Earth with respect to essentially the local ether. They detected that velocity, and there are now with ring laser gyroscopes, you can detect this all the time, 24/7, with a ring laser gyro that you can build in your basement, which was actually done by a guy by the name of Doug Moret. So, what this leads to is that the Sagnac effect is called a first order effect. That it's proportional to the velocity with respect to the ether divided by the speed of light. So it's much easier to detect than with the Michelson interferometer, which is a second order type experiment, because it with the mirrors, you're reflecting the light ray, and that cancels the first order effect. You're left with a much smaller effect that is much more difficult to detect. So the Sagnac effect, when it was discovered in the 1913 by George Sagnac, by essentially sending light rays around around a circular table in opposing directions and rotating it. When special relativity type explanations are attempted, they always assume that it's due to the area enclosed by the reflecting light path and the rotation rate. Whereas the Sagnac effect is actually very simple. If you imagine a pond and a boat in the pond, in the middle of the near the middle of the pond, then you drop a rock into the middle of the pond. The water waves propagate out from the center, and if the boat is still not moving, it takes a certain amount of time for the wavefront to reach the boat. But if the boat is moving away from the rock, it takes longer for the wavefront to overtake the boat. So the distance, the propagation distance, is actually longer, and therefore the propagation time is actually longer, and the effective propagation speed is slower. And that's what's going on and that's all there is to it. It's a very simple explanation of the Sagnac effect, which is Sagnac effect that does not require rotation or anything else, that is made very complicated by special relativity attempts to explain it. And in fact, actually, is a very strong disproof of relativity, because relativity would say that for a straight, that rotation is required. You have to accelerate the reference frame or something, and would not work if you're talking about straight line relative motion of the source and the receiver. But that's not true, because, and there's an experiment done by R.U. Wyong Wang in 2003 that actually was published in Physics Letters, that where he took a fiber optic gyro, and instead of just having it rotate circularly, he had a straight line path and added into the loop, and showed that the longer the loop, or the faster the loop was running, produced an effect, essentially showing a linear Sagnac effect, and that can't be explained. It's swept under the rug by people that try to explain it in the context of relativity. How am I doing here?
No, things are fine. Keep going. No.
Am I making sense so far? Is anything?
Well, no. I mean, people are. I'm following it. It's, you want to keep. Obviously, you need to make enough of the presentation so people can get an idea of, what you're presenting, and then we can have questions for that. So, just keep going.
Okay. So. In Su's main paper, he has two of his papers are the most important. The first one is called the LocalEther Model of where is it? I had it. Oh well. Here it is. LocalEther Model of
Explain what you're doing as you're doing things. That will help people. What are you looking for and why?
Sorry, I'm trying to find the paper.
Paper about?
Of Su's paper called the LocalEther Model of, here it is. Yeah, this is it.
Maybe if you could expand that and then put it to wide, so make that the entire window, and then make the expansion wide so people can read it. Because right now, unless they're sitting at a computer.
I don't really expect anybody to try to read it at this point.
Yeah, but I mean, at least it'll be closer. So, okay.
There you go. Is that a little easier?
Yeah, a little bit more. Okay. All right. That helps.
Okay. So here's where he goes into defining the local ether and showing how the Sagnac effect.
Can you? I'm gonna. Can you hear me?
Yeah.
I mean, we're talking about local ether all the time. I know there's entrained ether. Explain to a person who has no idea what local ether means instead of just ether. I mean, you said even Michelson and Morley also talked about it. Give it to us, in a simple terms. Where's the ether? Is it moving with the Earth? Those kinds of things. Can you give us some explanation for that?
Okay. We go back to so when in the 19th century there were actually two competing ideas about the ether. One was that it was the same everywhere. It's like it was.
The Earth was moving in the ether, correct?
It's the same throughout the universe.
Right. So bodies were moving, and the ether was sort of a stationary frame somewhere.
Exactly, stationary frame. One frame for the whole.
Right. And what was the other?
Sorry.
Well, what was the other one you were saying?
There was the Stokes ether, which was an entrained ether, but it wasn't well defined, and there were some objections to it. And I guess the most influential physicists of the time, like Lorentz and Poincaré, promoted the universal ether idea. So that was kind of the mainstream idea.
And so how does local differ from all that? Okay, so you're saying it's not like the mainstream idea where it's like a frame in the universe where everything's moving through it. It's not like entrained ether, which is basically as ether is close to any large body that it's actually moving with the body. What's the difference? What's local ether?
Yeah, that's local ether essentially.
Well, but that's what that. Yeah, you're saying it's not entrained, but
it isn't trained.
It is trained. Oh, okay.
But the twist that I was mentioning at the beginning is that it doesn't rotate with the celestial body. Its direction is fixed in space. So it's like as Beckman explained it. It's like a dancer with a hoop skirt, but the hoop skirt is not attached to her body. So as she spins, pirouettes, the hoop skirt doesn't move.
So if you're doing a Michelson-Morley experiment, the Earth's rotating, wouldn't you get some difference in so instead of an ether wind, you're dealing with something that's not moving? And if it's not moving as well, it's not moving as compared to what? Just the entire universe?
The Earth is the dancer that's spinning.
No, I understand that, but okay, and you have entrained mean, but entrained, you're saying it's not entrained. It's what, more ether around a body and less ether as you go away. Is that what you're saying?
Well, the strength of the density of the ether reduces as you go away from the. Okay, so. All right. Until it matches the density of the body that's embedded in. As you can see here, eventually the sun's gravitational potential matches the gravitational potential of the Earth. So that's where the influence of the Earth's local ether ends, and you switch into the local ether of the sun.
Okay, so is that a density difference? Is what you're saying?
It's a density difference and a gradient difference.
Well, yeah, right. Understood. Okay, gotcha. And again, I'm not criticizing anyway. I'm just trying to understand myself visually. I want to.
I'm glad to.
Yeah, and so okay, so. In some sense, the thing it shares in common with the ether of the 19th century, Michelson-Morley, before the 20th century, is that it is a frame, right? The difference is
it's not one frame; it's different frames from different positions in the universe.
Well, I'm talking about the ether itself. The speed of the ether, other than it's going back and forth, is ether moving in any way? Because you're saying the difference is it's not spinning with the Earth, for instance, right? So right. If it's not spinning, it means it's
local frame.
Right, but I mean, if it's not spinning, it's not spinning in respect to what? The Earth, right?
It's not spinning with respect to the rest of the universe.
Right. So if the
Have you heard the Earth-centered inertial reference frame?
Right. I understand all that. What I'm saying is the twist that you're saying that this theory puts on it is that the entrained ether, if you think of ether like water, and it would be more of the traditional entrained, you spin around, the water sort of starts spinning with you a little bit. As you go further away from the body, of course, it's not spinning very much at all, and eventually it's just not really felt. Here, what you're saying is, no, the Earth's spinning in the ether if it's like a water, but it's not really like a water because it doesn't spin with the Earth. It spins, and there is so that is, while the Earth's spinning, it's spinning, and the ether is, if you were to put a marker or a coordinate system on an ether particle, it would be staying still in space, and the Earth would be, as the Earth would spin around. Is that correct?
Spin within it, correct, rotate within it. And if you think of gravitational potential, it doesn't rotate with the Earth or whatever body it's coming out of.
Sure, but the ether, though, unless it's a gravitonic field, which is made by gravitons going in all random directions, this ether is going to be, if it's not going with the Earth, it's got to be in some type of reference frame. So the ether that's surrounding the Earth and the Sun is in what kind of reference frame then?
Well, like you said, each inertial reference frame is unique for that body.
No, I'm not talking about the Earth and the Sun. I'm talking about, don't think about the Earth and body. I'm just thinking like this.
Don't try to think about the composition or what kind of particles it might be made out of or not, or just.
But if but I understand what you say. Not think about that, but then you tell. Then I guess and again, I'm not arguing. I'm just trying to understand. That sort of goes against the idea that think of the Earth as a dancer spinning in this hoop skirt, and the hoop skirt stays still. The question, especially with people who are looking at relativity and reference frames and inertial frames, whatever, will be say, okay, it's still according to what? So but you said something to me which sort of answered the question, which is it's like the older ether where the ether is sort of a universal sort of reference frame. There's more dense, there's gradient in the ether. The only difference, it doesn't spin with anything that happens to be spinning. Let's say we got a body that isn't spinning compared to the ether frame. What I'm saying is that frame, you did say it was like the frame for
gravitational potential.
No, it's like the frame of the older ether, which is like it's sitting there. The Earth's moving through it. What you're saying is that as the Earth's moving through the ether, the potential of the ether field or particles, because it's got to be made of something, are those. The density is moving with the density is moving with the body. Is that correct?
Okay.
No, I mean, is that correct?
Yeah, that's fine.
Okay. Oops, I'm getting all this wrong. Hold on, I got to get these. There we go. Okay, so all right. So the density's changing. So if I'm an ether particle and the density's changing as the Earth's rotating around the Sun, for instance, the potential or the thickness of the ether, or the the density of the ether is around the body is measurable and pretty much same all around, just like gravitational. But if I'm an actual ether particle, if I put myself standing on an actual ether particle and the Earth's moving by, what happens? You're saying the ether doesn't travel with it, is that right?
Not sure I follow you.
Okay, you have the Earth there, which is that little blue ball, or is that the moon?
Yeah, that's the blue ball.
Right. Okay. So that blue ball, the gradient that I'm seeing is the gradient that is in the end turns out to be gravitational, but it's a gradient in the ether itself, right?
Yeah.
Okay. And as that blue ball is moving around, that little hole sort of or that gradient moves with it, right?
Right.
The question is, and it's just a mechanical question, is the ether, what you're saying, the ether itself isn't moving. So as it's moving, ether around bodies is, the gradient stays, but the actual ether particle itself, it's going to move on, and the Earth's going to move on, and the ether will stay. So if I were to take a spray paint can and paint one of the ether particles in your gradient, and the Earth comes by it, it will, go back and forth. Maybe it'll move forward or backward, whatever. But as it goes by it, it will then remain more or less in its place. Obviously, it's going back and forth, hitting in other ether particles to transmit waves, I guess, for light, right? So that's what I'm asking, as the gradient changes, but the ether particles themselves will stay. So if right where that Earth is right now, if there was an ether particle that was a foot above the ground, and then that Earth is 1,000 kilometers away, that ether particle is now 1,000 kilometers away as well. Is that right?
That's a question. Does the gravitational potential...
No, I'm not talking about the gravitational potential. I'm saying that ether is made up of particles in this model, correct?
Whether there are particles that are carried with the Earth, or as you say, the gradient is instantaneously affected by the orbit of the Earth. I'm not sure. Actually.
Okay, you're not sure. Okay, and if you say if they move with it, the only difference about that not being the same as normal entrained is it's not rotating as well. That's the only difference.
That's the key difference.
Okay, gotcha. Okay,
that resolves things like the Simorley and Sagnac.
Okay. I've asked a lot of questions, but I think I've got a picture of what your model is. My idea is, again, to understand your model from your perspective. So, okay. All right, and I will let you continue.
So, one of the another primary example of the evidence in favor of this LocalEther model is the GPS. So one fact about the GPS that is really contradicts relativity is that all the clocks around the Earth and on the GPS satellites can be synchronized. And according to relativity, they actually can't be. I think one of the big etherists, Ashby, even talked about a local ether effect surrounding the Earth to explain the fact that all the clocks can be synchronized, as if there is an absolute time. Whereas, according to relativity, all the different velocities of the satellites and different locations of the ground stations, or even your phone when you use Google Maps, should all be having different relative velocities and different clock rates. And then on top of that, there's what is called the pseudo-range correction that's built into the algorithms for every GPS receiver. Essentially, where the motion of the receiver on the surface of the Earth, when it's moving with respect to the ECI, or the local ether, because of the Earth's rotation, if the receiver is moving away from the satellite when it emits a pulse, the Sagnac effect, it's actually a linear one-way Sagnac effect. It has nothing to do with rotation. the change in distance between the satellite and the receiver has to be factored in. Whereas that's not really allowed by relativity. And he also shows that there's a phenomenon called the intercontinental microwave link, where you have two ground stations, one located in New York and one located in San Francisco, say. They send pulses to each other and record the time of transmission and reception, and they find that relaying them through a satellite, possibly a geostationary satellite, they find that there's a difference in the time of propagation if the signal is sent from San Francisco to New York. It takes longer to get there by tens of microseconds than if it's transmitted the other way from New York to the signal that's transmitted over the same path at the same time from New York to San Francisco. And again, this is due to a one-way Sagnac effect, where the transmission distance, the actual propagation distance changes due to the rotation of the Earth with respect to the ECI, which is the reference frame for the local ether. Does that make sense? Okay, and a third point here is that the interplanetary microwaves is originally discussed by Shapiro, shows that it's the relative motion of the receiver of a microwave pulse sent from the Earth to either originally was done by reflecting it off of the planet Venus, and now it's done routinely reflecting or transponding signals to interplanetary spacecraft, either on Mars or around Mars or on the way to Mars. The same effect of the Sagnac effect occurs, but it's due to the sun's local ether. It's traveling most of the time through the sun's local ether, which is well, anyway, this local ether theory is shows that difference in or switchability of reference frames or propagation medium that are you have to measure your receiver's velocity switches from the Earth's local reference frame to the sun's. So as I already explained about the Michelson-Morley experiment. By the way, this also, as Hayden and points out, would be much easier to detect the local ether with a microscopic interferometer if you did it on a spacecraft in low Earth orbit, because the velocity of the spacecraft with respect to the ECI, or the local ether reference frame, would be much higher, maybe 40 times higher, leading to maybe a 200 higher effect on for an equivalent interferometer. So one of the problems of the original Stokes entrained ether model was explaining aberration, stellar aberration. With the local ether model, actually, it's fairly simple. The assumption was back then that the aberration didn't occur until you got to the receiving telescope. The shift in the angle of the apparent direction to a star. But with the local ether model, the alteration of the angle of the wavefront actually happens out where the local ether of the Earth transitions to the local ether of the Sun. And Beckman actually had a paper that explained how this happens. That all the questions about like the area experiment where they put water in a telescope were all kind of for naught, because according to this theory, the alteration of the wavefront took place far away, somewhere past the orbit of the moon. So entrainment or not, this is a method that this shows how it could happen. By the way, I wanted to also mention this book by Tom Bethel, called Questioning Einstein. He was a friend of Beckman's, Peter Beckman, and he supported Beckman's local ether model. And
is that available? Can you get that book anywhere?
Yes, that's actually still available as an ebook on Amazon.
Oh, okay, cool.
And I think it's about $9 or something like that. It's not very bit expensive.
Whew, that's a lot, but we can. Okay, that's good. That's good. We got to work on getting Peter Beckman, maybe get an ebook, talk with that guy.
That would be great, because one of the benefits of this defining a local ether around the Earth is that it leads to, he was able to essentially derive the Schrodinger equation of quantum mechanics using just classical electromagnetism and the idea that there's a stationary reference frame, or at least one that is only moving at approximately 300 meters per second, that a particle like an electron is moving against. So there's this thing in electromagnetism called Lenz's law, that whenever you try to accelerate a charge, there's a back force, reverse EMF, it's called, that works to decelerate the particle. And this leads to an alternating acceleration and deceleration of the particle, very, very small compared to the particle's average velocity, like an electron. But it's like a hop. The the electron is accelerating. It's slowed down by the self EMF because it's charged, and then it accelerates again, slightly faster than the average velocity.
So a couple of questions. So is there any talk in the local ether about what charges or how it relates to the ether? Like
No,
you have an
not at this point.
electron. Okay, not at this
Charge
point.
is still a mystery.
And magnetism as well.
Essentially, yeah. The fundamental nature of magnetism, I don't think is clearly understood. But
Okay, not
it's a
in
lot
this
better-
not in this model. Not in this
So
model
it's-
then.
Well, not at this model with the current level of development. The point is that you can go very far without trying to ask those questions. And at some point, you would like to ask them, but with relativity, you're not even allowed to. It's just
What you're talking about is the local ether theory. You're pretty much talking about electromagnetism and gravity. Would I say that too?
gravity and quantum mechanics.
Okay, and you haven't talked about the quantum mechanics very much yet until now. I mean, up till now. Is that correct?
Right.
Okay.
First, you have to get past the idea of an ether. Then you can see where you can go beyond it. That's why Beckman called his book Einstein plus 2, is because he starts with Einstein plus 0. He has 3 sections to his book where he tries to show how the experiments that supposedly prove Einstein have alternative explanations in a classical mode. But then in section 2 is where he uses the idea of a local ether to derive quantum mechanics, to derive essentially the Schrodinger equation, which is the essence of quantum mechanics. And in fact, that's what first attracted me to, one of the things that first attracted me to Beckman's theory, because my father's Tron theory also postulated the oscillation of the particle in terms of its size that he called vibra, that led to this oscillation in the velocity of a particle, which, by the way, the idea of it, that the wavelength of this oscillation is essentially the Bernoulli wavelength. So it's not just imaginary.
Okay, maybe if you could explain a little bit for the people in our audience who are not super familiar with Schrodinger's equation, how and why that's important, even to quantum mechanics.
Well, Schrodinger's equation essentially says that there's a wave property to matter waves.
Right.
Whereas Beckman essentially Beckman shows that the wave is this oscillation, which actually generates a tiny magnetic field oscillation and electric field oscillation that participate in accelerating and decelerating the particle, which may in fact be the pilot waves.
So is the wave that Peter Beckman's using, is the wave in the ether?
Uh, well, it's an oscillation. It's an oscillation of the fields around a particle as it's accelerating and decelerating.
Right, but what's the
I wouldn't
field?
call
Is
it
the
a wave in the sense that
well, yeah, but I mean,
it doesn't
the,
propagate like a classical.
understood. So if there's an oscillation, that's understood. Now, is that oscillation happening in the ether, the local ether?
Yeah.
Okay. So what is that part of Coulomb's force, or that keeps the electron going around the nucleus, or not really?
Well, he shows how this oscillation of this harmonic speed change, when you consider electrons orbiting the nucleus, means that the stable orbits are the ones where you have a integral number of oscillations around the orbit, and how that leads to when an electron switches its orbital to a higher level, it has to change its number of integral oscillations, and you're going to have an emission of a pulse of EM waves. I don't want to call them photons because
Right.
I mean, the whole point of, or one of the beauties of Beckmann's idea is that it dispels the wave-particle duality. It shows that the wave nature of particles as they oscillate in a wave-like manner, and oscillating fields around.
So are particles like oscillations in the field?
No, a particle is a particle. It's real mass.
Okay.
But its oscillation in its speed is the wave-like property of the particle.
Okay, so the particles themselves oscillate, is what you're saying, or the field around it?
Well, the Tron theory, the particle's volume and radius is oscillating, but Beckmann is just talking about the oscillating fields being generated and the speed change.
Okay.
So it's like you know about full wave rectifiers?
I'm not familiar, no.
Well, anyway, there's a DC component that comes out, but then there's an AC fluctuation around that because the filtering is not perfect.
Mm-hmm. Okay, so you're saying basically Peter Beckmann generates the Schrödinger equations in his way with the ether model. Is that correct?
Right.
And so,
just the idea that Maxwell's equations are valid, and there's a fixed reference frame for a particle to move within. Whereas with relativity, it's all relative. There's no
right. Understood. So that's where you get the frame of reference versus relativity, which has its inertial frames. Is that correct?
So we're saying there's a preferred reference frame of the ECI or the local ether that's at rest, that the Earth moves around within.
Mm-hmm. Okay. Alrighty, we're at 11:30. Did you want to present a little bit more before we have anybody who wants to make any comments or have questions?
I just wanted to briefly talk about the time dilation, and Su has an explanation for that does not involve Uh, does not involve relativity. Whereas he just takes quantum mechanics equations for granted, essentially, although he says that you have to take them in the context of the preferred reference frame of the ECI/LocalEther. And he postulates a wave equation we call the LocalEther wave equation. And he shows how if you include the electrostatic potential and the gravitational potential in that equation, that it shows A, that the effective mass will increase as a particle moves with respect to the local ether at a high speed, and B, that the frequency of a transition of a quantum state of an atom changes due to this interaction with the electrostatic field, moving with respect to the ether, essentially. So that the faster the clock moves, like in an orbit around it of a GPS atomic clock, the atoms are frequency of oscillation, and essentially the resonant frequency of a cesium gas in an atomic clock lowers. And that it's a real physical effect, not just the result of applying an equation like the Lorentz transform. So it's not time that's changing; it's just the frequency of the clock. It's like temperature affecting the frequency of a clock, or air pressure, whatever. There's no air pressure.
So it's like
space.
It's what people in the MPA for many decades have been calling clock retardation.
Well, it's actually a change it's a physical change to
yeah, that's what clock retardation.
Of the clock. Well,
right.
Well, we call that time dilation. I don't
know. No. In fact, the reason we use the phrase clock retardation is the clock is slowing down, not time.
Okay. So
that's what I'm saying. When I got involved with the MPA way back in the mid '90s, they always would talk about clock retardation, meaning a clock on a GPS slows down in space not because time's slowing down, but because the physical clock slowed down. So there is a retarding of the clock mechanism, and so that's what you're saying.
Yeah. And okay. Su in this paper here, a local ether wave equation in speed-dependent mass and quantum energy, actually derives the v squared velocity squared formula. And then he also again applies the gravitational potential to this equation, incorporates it, and shows how the frequency of the oscillations of the atoms of the atomic clock increase as you go to a higher altitude, farther away from the surface of the celestial body, where the magnitude of the gravitational potential is lower. And alternatively, did I say the clock rate speeds up? The tick rate speeds up. It shows how the gravitational potential causes that physically, not again due to some space-time formula of general relativity. and alternately, as you get closer to a massive body like the sun, the tick rate slows down. You have a gravitational red shift. The speed of light slows down. All of those effects explain the bending of starlight when it grazed the sun. That was originally, obviously, or not obviously, but that was one of the big predictions of Einstein's general relativity that led to his fame and fortune, and being anointed as a physics god, essentially. It also explains gravitational lensing, that the bending of starlight around galactic clusters and galaxies. Now, I know this is kind of contrary to Dowdy's ideas, but I don't know exactly how his ideas explain gravitational lensing by galaxy clusters. Anyway, that's how Su does it, and he explains things like the Haffel-Keating experiment. By this mechanism, it shows that if you consider the Earth center, the ECI frame, and you fly a jet around the outside of it, and fly jets in counter propagating directions. Really find it. It's quote that.
So are you saying that you support the data from the Haffel-Keating that there was actually a change, or you don't?
Well, he does, and I guess I do too.
Okay.
In fact.
Okay.
Because he shows how it happens. The clock rate slows down. There it is. Because of the velocity of the airplane, of the jet, but it slows down less in the westward direction compared to the geostationary clocks, because it's based on this. The speed is based on the ground speed of the jet, but its actual speed with respect to the ECI is less than the geostationary clock. The geostationary clock is also moving.
Is this
ECI?
Is ECI is again?
It's the LocalEther reference frame. It doesn't.
Okay, gotcha. Okay, ether.
The Earth
Okay,
rotates within.
right. Okay. So is this a statement of prediction or a statement of matching data from that experiment?
It's matching data. Here you go. Consider the atomic clocks aboard a circumnavigating aircraft in a Haffel-Keating experiment. According to the LocalEther Model, speed and the mass variation factor.
Maybe it's more of a prediction of how he expects it to behave than it is to compare to the actual experimental data. Is that right?
It shows how the experimental data was valid. That the total time, the total number of tick rates of the westward traveling clock indicated that they were ticking faster than its geostationary clock.
Okay. Okay. If you want to maybe just wrap up for today in the next couple of minutes, and then we'll have people who have questions or comments. And if you're in the green room, let me know. If you have any questions or comments in the chat, just put them down as question : or comment : and I'll put those on screen for him to see. People in the private chat, I can grab those. I look at those once in a while, but that's usually in between the people in the green room. So maybe just wrap it up in the next couple minutes, so we'll have about 15 minutes to have questions or comments.
Well, essentially, I really think this is a great paradigm shift possibility to an alternative to special relativity and general relativity, and that even Su admits that it's not, he hasn't addressed every phenomenon that's out there, but that the comprehensive scope of phenomena that he does address, both for EM propagation and quantum mechanical type phenomena. He has a wave interpretation of the Compton effect, and the list is like at least 30 or 40 different phenomena that he addresses in a series of 20 plus papers, including. So, the best, if you're curious to learn more, the best option is to get his book, which currently you can get an ebook copy from a Taiwanese website, which I can, or to get a printed copy is a little more difficult.
Yeah, well, maybe is there a website people can go to?
Well, there's a paper that I wrote that essentially an overview of what I've been trying to describe today.
Of course, sure.
Which includes all of the papers that he wrote and the abstracts of them, and URL direct links to them, as well as instructions on how to access the ebook. So I think it's about $20 on PayPal.
Okay. Alrighty, folks. Maybe we have some people in the green room who want to make any comments. If you have any questions, okay, I got a couple people, so let's get them up here. James Keen, let's get it to more like this. There you go. Hello, James. You're muted. Unmute yourself. Okay, do we hear you? Say hello.
Thank you, Jim, for the presentation. From another Jim, me, who's not an expert in all of these ether literature and studies, could you explain at, let's say, a low level, a simple level, any difference between your local ether theory and what we hear about this ether drag idea? I'll await your answer.
Well,
thank you, sir.
Well, entrained ethers are essentially the equivalent term is a dragged ether. It's an ether that's carried with the celestial body. Like I've been trying to explain, this is an ether that's carried with the Earth, or for the Sun, there's a local ether it's just a different density, but it's carried with the Sun in its orbit around the galaxy, and then the galaxy has its own local ether, which it carries with it in its motion in the local galactic group, Virgo cluster, and maybe even larger cosmic organizations. Does that make sense?
So your local ether theory is similar to the idea that one hears about of this ether being dragged as the Earth rotates and so forth?
Well, as
It's
I was
different, or
trying
it's the
to make the point, is that the critical difference here is that it doesn't rotate with the rotation of a celestial body.
Okay, so
it's like the galaxy.
You're not in the ether drag camp.
Sorry?
Okay, thank you.
No. Okay. Yeah. Okay.
Again, try to think of the gravitational potential. That it's just GM over R, where M is the mass of the body and R is the distance from the center of the body, and how they all add up and how they all move with celestial bodies that generate them. That's the same idea for the local ether.
Here's a comment from somebody, Kimbo Ojo. Another imperfection is that light will be longitudinal wave in this model, but the light is a transverse wave. Is there something that you can say about longitudinal versus transverse in this model?
Well, first of all, I would say that let's not worry about that at this point. It's again, relativity doesn't try to explain the physical nature of anything. It's just equations. At some point, we can try to define the detailed properties of the ether. But I would point out that in terms of longitudinal versus transverse, yeah, of course, EM waves are transverse. And of course, a fluid by itself, without anything applied to it, would not support transverse waves. But think of an LCD, liquid crystal display, your calculator or your computer screen. It's the presence of the field that alters the properties, the reflectivity, polarization of the fluid. So you don't have to have this elasticity built into the ether pre-existing until the field passes by. It's the passing, it's the application of the field at the point in space where it exists that alters the properties of the ether to support this spring-like effect to restore the density of the location.
We have lost him, so maybe make let me get him down here. Computer may have frozen up. Ian, did you have a comment or anything, or you really had a question? I can bring you up. Go ahead.
Yes, I'd like Jim to say a few words about one aspect, David,
Okay.
because it's quite fascinating, and Sue has developed this very comprehensive theory, which I suppose ultimately is based on the sort of the Stokes concept, which unfortunately was dismissed quite early on. But the one thing I'd like Jim to say a few words on is the following. I think we've touched upon it before. The first Michelson-Morley type experiments, the second order type experiments, were not accurate enough to pick up any variation in light speed, if you like, or transmission time, owing to the the spin of the Earth, the rotation of the Earth. But I mean, as these experiments got more sophisticated, and the substitution of things like resin cavities for mirrors, as was touched on earlier, you would expect those to be picked up. And in fact, famously, as you well know, Jim, in 1979 in the Bryant Hall, actually you referred to it briefly, experiment, there was a signal of 17 hertz, I think it was, which couldn't be explained and actually was dismissed as spurious by the experimenters, but then was subsequently analyzed by people like Aspin. And he said that showed up the spin of the Earth at the position where the experiment was undertaken, which was Colorado. Now, my question is this. I'd like you to say a few words about it, maybe. Since 1979, indeed, as experiments have got more and more accurate, and the precision has increased considerably, and a lot of these experiments have been undertaken ostensibly to check Lorentz invariance, and they're down to 10 to the minus 20 and God knows what. And so my question is basically, how are these all explained away? I mean, you'd expect these to be picking up the effects due to the ether, the local ether, if you like, not being carried by the Earth in its rotation. And I think in the past you might have said, well, these are because of averaging or something like that in over periods of time. But I'd like you to explain that in a bit more detail, if possible.
Yeah. Okay. First of all, if you don't rotate the interferometer, there's no hope of measuring anything, because when you talk about the Earth's if the ether wind is due to the Earth's rotation, its direction is constant, due east-west, and the only way to see a difference is to rotate it. And a lot of the early resonant cavity experiments, relative early, what I mean around 2000 to 2005, and the Kennedy Thorndike experiment, were fixed in direction. They didn't rotate them. Did you know that? Well, anyway, the more recent ones,
as far as the Earth was carrying them in the rotation,
because they were basing their ether model on the universal ether model. So they were expecting to see a change as the Earth rotated relative to its motion against a universal ether. So they averaged their data that way. They didn't, and this 2 omega signal, twice the rotation rate of the interferometer, they averaged it out, just like Bryant Hall did.
But Bryant and Hall got a signal. I mean, whether they averaged it out or not, they got a signal.
Their final results,
they explained it away.
They explained it as spurious.
Yes. So what did the others do? I'm saying, did they not get similar signals? I couldn't find them in some of the papers I looked at.
It's hard to say. Some of them talk about it. Even one of the most recent papers by Nagel says that there was a signal that could be a real signal, but he said it was probably just due to the rotation with respect to the Earth's magnetic field causing some effect that he didn't really know about, that they couldn't explain, but that it was. And they talk about maybe repeating it with better magnetic shielding, but I don't know if they ever did. So that's, I mean, anyway, as Harry Ricker pointed out, Zaffi also recommended a Michelson-Morley experiment in orbit, as well as Wang and Hayden and several other people. There was a paper published in 1986 in Nature where 2 physicists recommended a MMX in space. But since people are so convinced that relativity is 100% certainly right, the experiment could never be approved by any kind of mainstream community like NASA. It would have to be done private funding. Does that make sense?
It does, yes. I suggested, I think, the other week, maybe somebody like Elon Musk, but I don't know. Perhaps he's not totally convinced by mainstream thinking. But
well, he certainly got enough money that he wouldn't miss it.
Mainstream, like NASA.
He certainly got enough money that he wouldn't miss it if
right.
he did fund it.
Right. Thanks very much.
Okay, Jim, we're going to wrap it up for today. We got 2 minutes before we go out of here. I want to thank you very much for your presentation. And again, where can people find more about this gentleman's work and your work? Is there a website or some place they can go, something they can search up easily and get there?
Yeah, I can post the link to my paper, which is probably the easiest way to find all of his papers and access his ebook. But there's no.
Okay. Well, I think they can also go. They can go to. There should be. Yeah, I think so. But if you go to naturalphilosophy.org and you register, you can get in there. You can speak directly with James. He's there and often discussing things in the Ether group. So at that point, you can get more information if you're interested. But thank you so much for your presentation today.
Can you
yes.
post it as a comment?
Yeah, we can do that. Yeah, you can. I think the best thing would you be able to go in there and do that, and then I can actually put it in the comments. That would be fine once the video's done, I can go in there and add that to both the description and if you add it in the comments as well. Okay?
Great. Well,
all right.
Actually, the message I sent you describing the talk has the link.
Okay. That's good. I will check that out and see
the two papers by Su that are the most important, I'd say, to start with.
Okay, so 2 papers from this link by Su would be what you're saying is the most important. Let's see here if I can, there we go. Maybe I can put this here. I'm finding it on the website here. And there we go. So it's under ResearchGate, LocalEther Model and Quantum Mechanics Theory. Is that the one?
That's mine.
Okay, that's the one.
All the other links in it.
Okay, so I'll put that right now. I've got that, and that's in the chat on all 3 channels, the YouTube and the Facebook channel. So it's being sent out. We got it out there, so those people watching can read more about it. All right, well, James, thank you so much. All right. All right.
We talk so much.
No, that's why we're here. That's why we're here, so everybody can get new ideas. So thank you so much. All right, that was really very interesting because we know lots of different ether models, but this one is similar to entrained, but it's more like the gravitational model, as he said, which is the gravity field doesn't move or rotate with a body, for instance, in a celestial body. The gravitational field is there around it and acts upon a body. He's saying that ether's density or gradient is the same thing, and that not only is a medium for which light propagates, but it also would be able to describe gravity. So let's take this on out. We are at 2 hours, and we'll get out of here. As I always say, stay critical, stay thinking. I'm Dave D. Hilster. I'm your science therapist trying to get you to the promised land of becoming a critical thinker. Ciao for now.